Okay, today what we're going to do is we're going to see about making a CFL flyback high voltage power supply driver using a flyback that come out of transformer out of Robert's broken TV. He broke it because he got mad and threw it. Anyway, I took the flyback transformer out and I bought a 10-watt CFL bulb, and I'm pretty amazed at what results I get with a 10-watt fluorescent lamp, compact fluorescent lamp. It's one of those ones with the swirls on it, the white tube with the swirly thing on it. You just take the tube off of it, and then you replace where the tube was, where your primary coil of the flyback transformer is, and you'll get amazing results. Now, I'll talk about this in another video, or maybe in this one later on how to find which is primary, which is secondary, which is ground, by showing you how to do that. Well, let's give it a go. I'm going to plug it in. Remember, do not try this at home. I repeat, do not try this at home unless you have the safety precaution. I should probably have it in a container with mineral oil in it so it doesn't arc over. I see it's arcing when I have it like that, but we'll give it a go. Hopefully it doesn't break. As you can see, it's working right now. You see it's arcing. It's arcing at the bottom too. Now it just stopped. It must have broke. Son of a bitch. That didn't last long. Is it warm? Does it feel, yeah, kind of warm. I wonder if it'll do it again if I hook it back up. Maybe it has to rest a while. Hopefully that's the reason. If not, I won't use this for my flyback driver. I'll just use a regular transistor, which I was originally going to use. Transistors there work. They got an oscillating source, which I'll probably use a function generator or something like that. Hope sometime we'll try it. May try it with a Dalton transistor array chip. They can handle up to 3.5 amps of power. We're gonna find that cord and plug it back in. And it's nothing. So I'm betting $1 that the CFL driver got fried. We'll try it again with mineral oil and see if that has anything to do with it. If it arcing back over and then breaking the CFL circuit. But I don't think it did. I think it has something to do with the type of CFL driver we're using. We're using a 10-watt one, which ain't the best thing to use. You probably want to get the highest wattage you can of those fluorescent lamps. And another thing is, I heard that they burn out, and this must have burned out because it was pretty strong. I have to say that it was pretty strong. It might be good for a good occasion to try it once in a while, but not do it all the time because they'll blow out. Anyway, I'm gonna feel it. Another thing's warm. Don't feel anything. But it did blow, and it did. You just saw it. It had pretty good arcing. I'll have to take a look in the camera and see what it got. Okay, now I'm going to show you how to find out in your flyback transformers which is ground, which is primary, and which is secondary. Primary and ground. On this flyback transformer, the one I just used, there were two pins. There was one named COL and another one B plus. So I guess the B plus is a positive, and CLL must be something else. Must be a negative. But why they call it COL instead of B minus? I don't understand that. Anyway, you want to measure you want to measure each pin like this to go between these two and see if you get a resistance of 1 ohm or something close to 1 ohm. There might be more than one that have lesser resistance, but we're going for 1 ohm. Not anything less, not anything more. And then after that, I'm going to show you how to figure out which is your secondary ground. What you'll need to do is you want to get a power supply that has the most voltage you can without going the most safe voltage you can get. This here I'm using 30 volts since I have a 30 volt power supply. Now what you want to do is you want to measure, but you put the positive on one alligator clip, connect it to one of the pins, and then connect it to your secondary on the meter, and then go to ground on the other lead of your meter, of your voltmeter. This here you use with a resistance meter, ohm meter. This here you use with a voltmeter to figure out the secondary ground. Now, on my transformer, the leader the second suction cup did not have a voltage on it at all. But that doesn't mean it's not bad. That means it's just your voltage is being dropped a lot and you can't figure it out. So what you'll need to do in case that happens is connect to a different secondary with less voltage. You'll have less voltage dropping since it's less voltage. And you'll want to try it again. And I got 5 volts on that time on it, or 30 volts I think it was. I did it from the 1,000 volt wire that's rated for 1,000 volts. There was one rated for 40,000 volts and 20,000 volts and 1,000 on the flyback transformer. I'm going to be getting a ballast. Wait a minute. Before I go, I'm going to show you how you hook it up to your CFL bulb inverter, ballast, or whatever you want to call it. Let's say this is what mine look like. Probably looks like the same on a lot of them. And then there's 4 points, 2 on each side. Now what you want to do with it is connect one primary wire to one side, both of them tied together, and then connect the other primary sides, both tied together. It doesn't matter which is ground, it doesn't matter which is positive. It doesn't matter. It's going to be alternating. The current will be alternating on it. How it works basically is that these CFL bulbs, they need a high voltage at a high frequency. The voltage doesn't need to be that high what the CFL bulb provides. It can run on 12 volts, it can run on 5, whatever you want to produce on it. But on the CFL bulb driver, you'll need to run on house current. And how that goes, you take the one that goes to the 2 wires that go to the screw base connector on the CFL bulb, we connect to our outlet cord. Now these only lasted about a minute or so, probably even less than that. I don't think it was even a minute it lasted. But I believe the reason why is because these are 10-watt CFL bulbs. They're not made to handle a lot of current that they'll require that transformer. Since it's a 1 ohm, acts like a 1 ohm resistor, it's a big load. This 1 ohm is kind of low for it. Of course, then when it alternates, you have the resistance goes up a little bit because of inductive reactance. states that if you have higher frequencies of a inductor, the higher the resistance will be. And why they're like an inductor. Transformer is like an inductor, except that it has more than one inductor inside it. So this wire here goes to one primary wire, and this set go here, tied together. So you have two wires like that. That's what I did. I believe that's correct because I used to make a CFL ball driver that drives CFL balls with a disposable camera flash circuit that would make a CFL ball light on it. Now the frequency matters. Frequency on it is probably around like a few tens of kilohertz, I believe, maybe 56. I think that's what I read on the instructable when I measured 56 kilohertz. But it worked amazingly. It worked better than my initial coil power supply. So I hope this helps you out if you want to build a flyback driver. You can try, the best way to do it is get one of those ballasts, those big long ballast that's made for those long tube fluorescent ones. They're stronger and they will last longer. I heard about that they last longer. They don't burn out like these CFL ones. So I guess that's about it for now. So I hope you enjoyed this video and hope if you do build the flyback transformer driver, be safe with it. Because remember, I've always